Welcome back, everyone. Today's topic, we are talking about samples versus populations and when you would use each of those, kind of what the differences are. When we talk about a population, this refers to the group where our information is coming from. And it doesn't just have to be people. Like if we were talking about, say, an apple farm, and we want to know what percentage of apples are not going to pass a quality control test, like say they got hit with hail or worms or they rotted or something like that, in that instance, our population would actually be apples. Or if we wanted to look broader at, is it this one kind of tree that always has problems? Then your population could be the tree. So it doesn't just have to be people, it's whatever group your data is coming from, that's your population. When we do a census, we are collecting data from every single member of the population. So if we had 40 trees in our apple orchard, we would be collecting data from each one of those 40 trees. When we use a sample, this would be like, okay, we can assume that most of those trees are pretty similar. So let's look at, say, only 10 of them, because it's a lot easier to work with just 10 trees. And then we'll assume that the rest of the population is going to behave the same way, and that makes our sample valid. That's not always the case, though. And that's when you need to do a census, so survey the entire population, because that will give you all of the data, whereas if your sample does not provide valid conclusions, like that's what you have to do in that instance. So if we look at our school, if we want to talk about the population, that would be all of the students at the whole school. So if we were doing some kind of survey that was a census, we would be asking every single one of you for your input. If we do a sample, so let's say we can assume that you all have similar opinions on, I don't know, if we need new vending machines, for example. What we would do for a sample is get 25 students from each grade, and then we'd have 100 students in total to work with rather than 700 or 800. So it'll be a lot more manageable in terms of numbers, and we can assume that that's going to give us valid data because there's no reason why that sample of students wouldn't represent the entire population. But what about when that's not the case? So if you think back to like 2 weeks into our online learning, I put up a Google form, which is basically a survey. And when I give a survey to our entire class, it's called a census. So I actually gave out a census, and again, this is like 2 weeks into learning, about how much time you were spending on my online courses. And the reason why I did that is because I wanted to make sure that I'm at about that 5-hour mark. Like there's some people doing a little more, some people doing a little less, but the average was 5 hours. The reason why it wouldn't work for me to just use a sample in that instance is because my sample might show me that, like let's say I, instead of using all 60 of you, let's say I only surveyed 10. And of those 10, maybe 8 were exactly average, and 1 was a little high and 1 was a little low. That tells me that I'm almost exactly on the average for my entire class if I try to extend that sample to the entire population. What actually happened, and why it's important for me to have data from everyone, is that we had some people who were a little below, some people were a little over, some people were in the middle, but some people were also quite a bit below, and some people were also quite a bit over. And then even within that, some people were like, I only did 1 hour 1 week, and then I did 9 hours the second week. So using that entire population data gives me a better idea of the number of people that I have who are at each step along the way. It doesn't just tell me about the average in the very middle. So the next example we have is with Stats Canada. They put out a census every 5 years, just trying to figure out how old people in each household are. And the reason why this one needs to be a census is because if they just used a sample, they might get a very reliable average that tells them, okay, the average person in Canada is, let's say, 45 years old. But that does not mean that if they go into any one specific neighborhood, that most people there are going to be 45 years old. That only tells them the average across all of Canada, which isn't very useful. So they don't use samples for this. What they do is they get a census so that they can figure out, okay, in this part of Calgary, we have this spread of people. So we have a bunch of really young people, we have some middle-aged people, and very few older people in this one particular neighborhood. But in this neighborhood over here, it's the opposite. We don't have many young people, we have more older people over there, and still some who are in the middle. That data is a whole lot more useful because when they're looking at like, okay, where should we build a new basketball court? Probably don't want to do that right outside of a senior center. That's probably not the best use of your money. But if you're looking at, okay, our senior centers are really full right now, where do we build another one? Well, it doesn't make sense to do that in the neighborhood with all of your really young people. So in that example, like yes, the average is still going to work out to be, what did I say, 45? But having the data on the entire population is a lot more useful for that case. So we have a company that has 3,000 employees and they want to know, should we get a fitness center, will it be used by our 3,000 employees? This company decided they could use a sample of 300 employees to get a decent idea what everyone else was thinking. In this case, it kind of makes sense because the average, if that's all we want is the average use of a fitness center, well, that can be extended to the entire 3,000 employees, assuming you got a random sample and it was a good survey. That could be a valid result for all 3,000 based just on the 300. Okay, I'm going to get you to pause the video here, think about these 3 examples, and then I will go through them. So we have a province wants to know if they should ban cell phones while driving. Obviously, we did this like, I don't know, 9 or 10 years ago now here in Alberta. But let's say it was before that happened. Is a sample useful in that instance? And I would say yes, a sample is useful there as long as it is a properly diversified sample, meaning that you have some people who can represent everyone's voice to cover the entire population. Because if you only sampled, let's use like teenagers who just got their driver's license as an example, if you only sampled those people, they're probably more likely to say, like, no, I can talk on my cell phone. It's no different than talking to someone sitting beside me. Whereas if you sampled, let's say, people in the older demographic, people who, especially when cell phones first came out, weren't super familiar with them just straight out of the box, they would probably be more inclined to say, well, no, I actually find it distracting to have to swipe to answer the call or to dial in a phone number. This should be banned while driving. So if you can get a sample that covers both of those voices, then that can be useful in getting an idea of what the entire population thinks. So those could be valid results. With a light bulb company that wants to know the average lifetime of their light bulbs, we're talking about an average here. So we just need to know like what is the middle, and then maybe a little bit of like how much does it vary on either side. If you use, let's say 10 light bulbs, think back to our example with 10 coin tosses. That was a small sample size, so it didn't really work out the way that we wanted it to when it looked like 70% of the time we got tails. But if we're using light bulbs and we only use 10, we might run into the same problem. But if we use 100, we're going to start to get better results, and if we use 1,000, we're going to start to get really accurate results. Light bulb company could have like 1 million light bulbs. They don't need to test every one. They can just take a sample, and based on how big they make that sample, they can get information that will be valid for all of the light bulbs. Other reason why you wouldn't test the entire population of your light bulbs is if you wanted to know lifetime, well, you have to burn them out to do that. If you're going to burn out 1,000,000 light bulbs, now you have nothing to sell. So that's really not going to help you very much. Last example, math teacher wants to know how many hours of homework you're doing every week. I already kind of talked about this one. This is one where we do need to know the entire population because we're not just worried about the average. Like, yes, I'm trying to hit 5 hours average, but if I have some people who are spending like 15 or 20 hours, that's something that I need to know about, even if my average is still staying at 5, because I need to be able to do something about that. Okay, here's some questions for you to work on.